and welcome to this second live talk show of GloComNet, portal of Global Complexity Network. My name is Connie Dahlstein and I'm your host today. This broadcast is part of a series of 6 monthly broadcasting programs around the theme of complexity. These programs, and thus this broadcast, are interactive, which means you can join us by active participation. By using a chat button below this page, you can reach the editor immediately, who will then try to get your question to the table. We remind you in advance that the number of signing viewers suggests that many questions are to be expected, and it may be that your response is not addressed. In that case, we will try to reach you in a different way after the broadcast with a response. So today we're talking about climate change policy, and joining me are Professor Lex Hoogtuin, University of Groningen, and on my left, for the viewer to the right side, Kees de Lange, physicist and politician and an avid influencer in the climate debate. Like our final guest, Marcel Krok, science journalist and writer of the book The State of the Climate. And for equality, we have agreed to address each other by first names. Welcome. Climate change, with a pun of words, is a hotly debated topic at the top league of the global agenda. Terrorism, poverty, inequality, global warming, and so on. And indeed, many argue that this is a larger threat to humanity than terrorism. And one dare hardly challenge that statement, as global warming has become a true religion. Supported by politicians, scientists, but also influencers like pop and media personalities, who each have their own agenda, global warming firmly sits at the center of attention. Many elements make it as well complex as uncertain. What to measure, which sciences to include, which numbers to believe, how to deal with culture and national interests, how to separate hype from the facts, and how to take a good view in such a short time on a topic that stretches back thousands, if not billions of years. Follow us today while we first dive into the content of the climate topic before moving over to how to link this project and this topic to a realistic global economic agenda or policy. Let's get to work. Gentlemen, I already said this, you all have a very avid interest in the topic. May I first go to you, Kees, and tell us what is your stake in this topic?
Well, it's long-standing. First of all, I am a professor of atmospheric chemistry and physics in Amsterdam. So professionally, I'm very interested, and I have the illusion I know something about it. Secondly, I've been a senator in the Dutch Parliament, so I'm also interested in the political angle, how to translate scientific results into actual policies. And climate and climate change, for that reason, to me is an excellent topic.
Yeah, perfect fit to the table. Marcel.
Well, I'm a science journalist with a chemical background, actually, and I'm following this topic now for over 10 years, almost full time. And I must admit that during the years I became like a climate optimist in the sense that the way the climate is developing is not that scary. And actually the scientific literature is less and less alarming, in my opinion. So I've becoming very optimistic about climate change. It is a serious issue, you could say, but it's not a threat, in my opinion.
Perfect. We already have a rare species at the table. Lex, over to you.
Yes, I'm interested in the topic because I'm interested in complexity and uncertainty. I'm a professor of economics, but also related to complexity and uncertainty. And climate change, I would say, is at least doubly complex. The first, climate itself can be seen and should be seen as a complex adaptive system.
Yeah.
And then if you move on to the issue of what to do about the climate, if you can do anything about it, then you're talking about economic policy. And economic policy making itself is a complex issue. So that's why I'm more than interested in climate and climate change.
So we have a perfect setting to get some content and then link it to the policy and the economic agenda. So let's first get some facts clear, because all of our viewers, we're not necessarily climate specialists or experts. So to start very simply, what is the difference between climate and weather?
Well, weather we have to contend with every day. If we want to predict the weather, and for economic reasons that can be convenient to do so, we have weather models, and these weather models have very limited capability. They can tell us at most 1 week in advance how the weather is going to behave, and much beyond that doesn't really work. Now, climate is a totally different issue. Climate is defined as, well, one could say, a worldwide average weather over a period of 30 or 40 years. So this long-time average develops in a certain direction, although it's difficult for every individual to really keep track of these very small changes. So when we want to study weather, it's relatively easy. You can look out of the window today and tomorrow and you get an impression. For climate, you have to rely on the records and see if you can find some trends in them.
Yeah.
So there's a big
Very
difference there,
view.
both in timescale, but also in the psychology behind it.
And then what is it that makes climate complex?
Well, the reason is actually the same as why weather is complex. It is influenced by a trillion factors, and that humans contribute to climate change is trivial. I mean, everything you do, building a house or planting a tree, it will influence the climate in some sense. But what is happening right now is that a group, that science has started to believe that the emissions of greenhouse gases and CO2 dominate this process, and that is what the debate is all about. So we now believe that after billions of years in which we have had climate change, that now suddenly humans are the dominant factor, and not by everything we do, but mainly by using fossil fuels and emitting greenhouse gases.
Yeah, and does that also mean then that now, as we so much look at the human factor, how does that impact the predictability of weather and climate?
Well, there is a nice quote attributed to Mark Twain. The climate is what you expect, and the weather is what you get.
That's actually a perfect quote, isn't it?
Yeah. But in the climate debate, there are also climate scientists who say, well, you cannot say this is actually not true, because climate is as unpredictable as the weather. And so also part of the debate is that people believe that, okay, we cannot expect the weather after a week, like Kay said, but we can at least say something about the average trend, yeah, that we will get a warming trend. But some other scientists even dispute this.
But so then how should we react to this? You're going to come to this.
If you focus on the models to begin with, on the predictions to begin with, scientifically you start at the wrong end. A scientist always starts with the observations first. And when you want to get observations on a worldwide scale, that is difficult enough. It may sound trivial, but it isn't. First of all, you need a representative network all across the globe. Then you need to make measurements over a period of maybe a century. And at the beginning of the century, the measurements have to be equally reliable as at the end of the century, which is far from trivial. When you've collected all these data, you can hope to construct a model. And the model is only realistic if the model can not only predict the future, but also predict or explain at least the past. And the present models go on and on about predicting the future, but they're much more limited about recreating the past. They're not very successful in recreating the past, and that makes these models, in my view, a little dubious when it comes to predicting the future.
Yeah, we have a question here from Dana in Poland, and she says, well, when did we actually start taking measurements that are reliable?
Oh, a little
Is that
over
a century
ago, yeah. You needed thermometers for a start. You needed the possibilities to measure pressure. You needed to do it on a worldwide scale. That's mainly the main predicament, of course. Even now, the measuring stations are in North America, in Europe, to a lesser extent in Russia even, less in Asia, hardly any in Africa. So to cover the world with a representative network is even today not an easy matter.
No, it's already a challenge.
Yeah.
And so how come that we all, apart from great communication, sort of seem to have bought into this message that if we do nothing, in X years, the world will be consistently warmer by whatever, 4 degrees. So if I listen to you, then that is actually almost a nonsense message.
Well, maybe it's good to give just a very short overview of what the debate is about, because
Please do.
some facts are uncontroversial. I mean, what is uncontroversial is that there has been warming. So the world now is warmer than it was a century ago. There has been an increase in CO2 concentration in the atmosphere, and it's pretty certain that humans contributed to this increase. But the problem is that the alarmists, so to say, the people who are very scared about climate change,
So far, so good, yeah.
they say this is already convincing evidence that there is a climate crisis. And other people like Kees and myself, we say, no, because this doesn't answer the crucial questions. The crucial questions are, how much warming are we going to get in the coming century? Will this warming be a problem? Will there be an increase in extremes, for example? There are a lot of talk about extreme weather, but so far, and this is actually admitted by the IPCC, the International Climate Panel of the United Nations, that so far extremes are not changing. So we don't have more hurricanes or floods or droughts or tornadoes or bushfires. So all these extremes, they happened in the past and they still happen today. And there is no increasing trend in them. And many activist groups, they claim that such extreme that we will get more extremes in the future, but there is very little evidence for this.
There is always the confusion between what a correlation is and what causal effects are. Even when you look at the slight temperature rise that we experienced during a century, there is hardly any correlation with the CO2 concentration. Certainly not if you look at the most modern ways of measuring temperatures via satellites. The satellite record shows that in the last 20 years the increase in temperature has been minute. If you look at surface measurements, it's a little different, but the debate between surface measurements and atmospheric measurements in the troposphere has hardly been solved. So there is not much of a correlation. Well, if there is no correlation, there can be no causal effect even. So causality is very doubtful in the whole matter. And of course you can say, well, forget about the observations. All I believe in are the models, and when I turn my computers and I turn for a day or two, I get the prediction that in 100 years' time the temperature will be up at 2 degrees. The hurricanes will have increased tremendously, and so on. But as Marcel is saying, from the observations as we know them today, there is no reason whatsoever to observe that hurricanes have increased, that the temperature has increased dramatically, that CO2 has increased dramatically. Quite the contrary, you can even claim that CO2 is fodder for plants. So it has been observed, it is being observed at the moment, that due to CO2, the planet as a whole is getting greener.
Yeah, and that is an interesting point, because I think there's a lot of confusion about the whole CO2 debate as well. So maybe you can point us that a little bit as well before we move on. Because everybody says, oh, it's CO2, and then we think about, you know, the industrial take-up in countries like, well, first Western Europe, now China, everywhere. How much truth do we put to that? Because before the Industrial Revolution, you know, we also had huge climate changes. Is it because we measure it now and we didn't sort of measure that then? and what is the truth about CO2 emission, if there is a truth about it?
Yeah, well, like I just said, there is an increase in CO2, and it's very likely that we humans caused a large part of this increase. So the question itself, is this a problem or will it be a problem, is a valid one. It's a valid one. The problem is that science has become very politicized and polarized, and some, you could say, activist scientists, they take it a step further and they say, there is a consensus that this will be a big problem, etc. And now a rational debate about it has become close to impossible. Well, Kees mentioned the models, and I think it's important to understand that the reason that people now say it's 2 minutes before midnight, is that the models show that in the coming century we might get 3 or 4 degrees of warming. Well, if that happens, that is really quite a dramatic change. I mean, 4 degrees Celsius is the difference between an ice age and an interglacial. Yeah. So that's a huge temperature increase. So indeed, that will generate a lot of problems and issues. My point is that there is a lot of evidence that the models are what we call oversensitive. The models warm up too fast. So if you add CO2 in the models, they will go up like this.
It's a hockey stick.
And the real world climate seems to be much less sensitive to CO2 than the models. So the climate debate among scientists now is, can we really trust the models? Yeah. And we have the Paris Agreement, and in Paris we have decided we should we should stay below 2 degrees centigrade of warming. We have now close to 1 degree of warming. So we still have, in that definition, we have 1 degree to go. And the models indicate that this could already happen in 25 years. But that would mean a huge acceleration of the warming.
Yes.
And my point over and over again is, we don't see this acceleration in our data, in our observations, not in the sea level rise, not in the temperature. It's going very slowly and almost linearly. And the debate should about these kind of things.
Yeah.
But maybe about the models, there's another point that should be made, which is that we have 100 models. There is not just 1 model, we have 100 models. Well, from the point of view of a physicist, it's funny, you know, we have 1 Schrödinger equation, 1 Dirac equation, 1 Dyson equation. Yeah. We have 100.
Well, actually we have 36, but they do different simulations with the models.
Yeah.
So
exactly.
They have different.
But why do we have so many different models? Well, the reason is easy. Not all the physics of the climate is well understood. When it comes to cloud formation, we know that cloud formation is important, but the fundamental physics we do not know. So how do we incorporate it in the models? Well, we parameterize it, so we put it in together as a parameter. And how do we determine the parameter? Well, by taking the model predictions and comparing them to the observations.
To the observation, yeah.
But you know, that doesn't tell you about the fundamental physics of cloud formation. It just tells you that cloud formation is a little important. But to what extent, we still do not understand.
No, and I think that has to do with the fact that we all know science is a moving target. Thank God, you know, it advances all the time.
Keeps me in business.
Exactly, but business people, politicians and other people like to take sort of a slice of the truth and use that as a starting point for the debate going forward, which brings us onto our next topic. But before we do that, maybe if either of you could sort of give us the 3 main findings, conclusions or statements of the Paris Treaty that we should remember for the benefit of our audience for the rest of the debate. So the 3 main outcomes.
Oh, there actually is only 1. And
there's only 1.
I mean, that is the 2 degree. Because that has become a very hard political reality. Yeah? Everybody has to act according to this target. But there is actually very little science behind it. So it's quite arbitrary.
And there's no understanding within a 2 degree zone for which type of country you are, where you are locally situated, what your rate of development is.
The Paris Agreement is not so much a scientific agreement, it's an economic agreement. When you look at the Bonn meeting that is still going on today, I believe, or closing today, I read in the paper that at the meeting there were 400 representatives from the little country of Ivory Coast in Africa. Well, I cannot believe that, in Ivory Coast we have 400 climate scientists.
No,
We
we
do
probably
have lots of
400
politicians in
climate
Ivory Coast,
Yes.
and they're all present in Bonn, but it's not a scientific meeting
No.
at all.
No. So, moving on then, climate and economic policy. So now that we've heard legs, this might be a truth, that might be a truth. And I'm not saying that disparagingly, it's simply a fact that we don't know all the facts yet. How can we then link those scientific insights into economic policy? How do we link this almost sacred belief with neutral economic policy that give us a good agenda?
Yeah, so like I said at the beginning, climate itself is a complex issue, a complex system.
No doubt.
I've listened again with great fascination about what we know and what we don't know, and even perhaps things that we cannot know, even after studying further. Then the next question is how to deal with that in terms of economic policy. And then we move from one complex issue, a scientific issue of what do we know about the climate, to the issue of how to deal with it in economic terms, which itself is a complex issue. And then I think it is important that we, in dealing with complex policy issues, we have to take into account certain principles in designing our policies. And let me mention a couple of those principles. I think the first principle is the principle of modesty. We have to be aware how little we can know in principle about a complex system. So that means, for instance, that you should not set policy targets that are very precise. That's simply impossible, simply irrational if you have to deal with a complex system. So that's a modesty principle. The second principle is a principle that comes from the famous economist John Maynard Keynes, who once said, "Don't attach too great weight to matters that are very uncertain." So that means that you do not have, you should look ahead, but you should not look too far ahead, because the uncertainty increases over time. So horizons should be relatively short. That's a second principle. Then a third principle, which according to some goes back to Hippocrates, which is in medicine, is what is called the do no harm principle. Take into account that a complex adaptive system is a complex adaptive system because it has adaptive mechanisms. Give the mechanisms a chance to play their
first to do no harm.
First, do no harm. It's in the medical oath that we have.
Very important.
And that's crucial. So in many cases, try to avoid that the medicine is worse than the cure. Yep. And that's a very important principle more generally. Yeah. And let me give a final principle for running policies in a complex system. And that comes from economics, and that comes from Milton Friedman in particular. There's no free lunch. No. Economics is not about religion. Economics is not about, let's say, giving absolute priority to only one thing. That can only be the case if you are in war, or if there is really something that threatens your existence. And as we have heard before, it is unlikely, let me put it mildly, that climate change is life-threatening. So it is a normal, I would say, a normal economic problem where you have to trade off the resources that you want to spend on it against other objectives that you may have. Do I want to spend X million for combating climate change, or do I want to spend it on healthcare or whatever? And that also applies to the means that you want to apply. Do I build solar systems? Do I build windmills? Or do I look at, perhaps it sounds old-fashioned, do I look at nuclear energy or things like that? So you have to make all kinds of trade-offs in making the decision what you do and how you apply your economic reasoning, taking
Yeah.
into account, I think as was vividly demonstrated, that there are natural limits to what you can know about a complex
Yeah.
system.
Yeah.
Yeah.
Well, in fact, with all these revolutionary statements at the table, we will take care that you get personal escorts to your car because we obviously don't have people who all drum the same beat here. So, but listening to you now, you're saying, okay, the modesty principle, don't look too far, do no harm, and make choices. Four very important principles.
Could I make
Yes,
a
please
comparison?
do.
Because this third principle, first do no harm, I use it a lot in public talks. Because what is currently happening in the global warming discussion and the policy response is that, in my opinion, okay, the planet is warming. So you could compare it to a patient who has a fever. Yeah? And in my opinion, a patient has a light fever. So let's suppose that for a couple of weeks, you don't feel so well, you have 37.5 temperature. Yeah. And you go to the doctor, then to the hospital, and they cannot find exactly what is going on. But it doesn't go away, and then the doctor, the specialist is saying, well, let's just try chemotherapy. And you're saying, well, what? Are you crazy? Yeah. Chemotherapy? I have a slight fever and I'm not going to use chemotherapy. And this is what is happening in the global warming discussions. Yeah. There might be something going on. We have had some warming, but is the patient, the planet, is it really very sick? Is it in danger? Does it have cancer? No, in my opinion. But of course you could disagree about this. But the policy response is comparable with chemotherapy. Yeah. Why? Because it's extremely expensive. So you take away resources from other topics, and it's not only expensive, but it's also a very inefficient chemotherapy.
Could you here also argue, because also part of the do no harm principle is give the, let's say, the own adaptive mechanisms a chance. Yeah. If I look at what's happening in climate policy, my impression is that there's a lot of emphasis on very uncertain prevention, perhaps even impossible prevention, and relatively little on adaptation. Yeah, that comes to my next point. I really would like you to dive into that and say, and give that a go, because obviously our viewers also say, well, is the only solution prevention, which is sort of what we're being spoon-fed. Yeah. Whereas, indeed, if you have a fever, the body will start to react as well. Something will happen.
There is an obsession with prevention, or what they call mitigation. Yeah, so they want to reduce the CO2. We have to prevent climate change. While, in my opinion, adaptation would make much more sense. It's it's much cheaper.
More realistic, maybe.
And you can help. Let's say the people in the Philippines. They had this typhoon Haiyan a couple of years ago. Several thousand people died. Why? Because they are poor. The houses are bad. Early warning systems are not working properly, etc., etc., etc. If we spend money now to improve infrastructure, etc., etc., the next typhoon will come. It will come. It has nothing to do with climate change. And we can help those people with better preparation for the next one. Yeah. Yeah, and the same you saw in Harvey and Irma in the US. They knew that one day Houston would be hit by a hurricane, but they didn't properly prepare.
No. There's another point, maybe not so small, but when we look at risks that threaten our existence, it's helpful to rank the risks in order of importance. When you look back in the geological times, it may well be that the impact of meteors on Earth has been a lot more life-threatening than climate change. So why don't we worry about the impact of meteors? We can do something about it if we want to. We are not even talking about it.
Some people do.
Well, some people
NASA.
do. Yeah, there is a group at Arizona State University that's very involved with it. I knew Tom Gerels, a former Dutchman, founded that. But we should know what risk to address first before we commit all our resources to a risk that may well be a minor risk compared to others. That's the point.
Yeah, but isn't it also that if you focus more on adaptation, that you're far more flexible?
Exactly.
That you do not give one shot a lot of money spent for many years, and you pre-commit for many years. Whereas if you focus more on adaptation, you can respond to what's happening.
And you
If
don't run
over
out of
time it turns out to be that
But
perhaps
from
you are wrong,
from
it's
day
more-
one, in the climate discussions, like starting at the Rio conference in '92, adaptation was a taboo. And nowadays it's mentioned many more times. In the Paris Agreement, you can search for adaptation. It's mentioned many times, but still there is an obsession with mitigation because of the 2 degrees target. You can only reach that with mitigation.
Yeah.
And so still adaptation is still like, in my opinion, it's still a taboo, and it's a pity.
I was in Canada this summer and I talked to the head of department for climate change, and their adaptation is considered much more important than mitigation. So there are trends in what I would consider, and you too probably, Marcel, the right direction.
And I would argue from, let's say, from the policy principles that you have to apply to complex systems. That's also a shift in the right direction.
Because it allows a gradual approach instead of the stop-go.
Yeah, exactly.
That's
A gradual
exactly
approach, and you can learn over time whether you were right, that it's perhaps just a mild fever, or the others that are more worried may be right, because you continue, of course, to monitor what's going on.
Yeah. So if we now listen to this, and you see this all the time, we see that politicians and other people, opinion makers, encroach on this domain because there's obviously value and currency in taking part in it. What should we then learn from this? If you look at global and complex issues as a whole, what should we learn from it? I'm not saying we should sort of, tell our politicians not to talk about it and stay away from it. It's a scientific topic, and so who should take the lead in those sort of literally global, large, complex issues? How would you organize it if you had a chance?
Yeah, I think it is important indeed to distinguish between the scientists who have the discussion among themselves on the basis of scientific criteria. At the same time, you cannot avoid that you have a political decision about these issues, but you cannot take political decisions exclusively on the basis of science, because politics in the end is about preferences.
Yeah.
So if given what we know about the climate, and it's uncertain, but then you have to have a political decision and discussion on how much importance you attach to trying to prevent it or trying to build adaptive capacity, how much you want to spend it and to, on it, and to compare it to other priorities that you have. I mentioned earlier healthcare, so the political discussion should be given what we know. Are we prepared to give another X billion to preventing, trying to mitigate, as it was called earlier, climate change, or should we spend the same billions on adaptation, or should we not spend it, or should we spend less and spend it on increasing healthcare coverage or whatever? And that's a political discussion.
That is a political discussion.
The problem is that the 2-degree target is by scientists and government scientists is calculated into carbon budgets. So and then targets, and the politicians are confronted with these targets. So they say, okay, we have this EU target, European target, and we have to reach it. And then they don't do a proper cost-benefit analysis anymore, because they know that if they do it, that it looks horrible. And the Dutch government, recently we had a new Dutch government, and their goal now is 49% CO2 reduction in 2030.
Yeah.
That's huge. And I calculate, I was interviewed by one of the major newspapers. I calculated, if we do this, how much less temperature we get in 2100 globally. It is 3/10,000ths of a degree. But so it's unmeasurable. So this is of course partly because Holland is a small country. But even if you calculate it for the US, but the problem is that the cost of this is tremendous.
It's tremendous and incalculable almost. It really links.
Let me add that figure that you proposed was supported by many people. I mean, it's not just your opinion.
No.
It's been, well, a scientific fact, in fact. And,
Yeah. I have a question here from the audience. Thank you very much. Jules Kneepkens. Thank you. And he actually talks to this point, and he said, we talk about governments walking away with targets, but his point is, should one not set challenging targets or objectives to get things moving? For instance, he said, if we don't set strict targets in aviation for less emissions, the manufacturers of those airplanes will not be, motivated to build engines that are cleaner. So I think his point very much is, on the target setting, should that not be more at a micro level and just hand out the targets to the various
Yeah, but
polluters?
it should be consistent then. And I do think that you may run into big problems if you run policies like we apparently do in the Paris Agreement. So my point is, if I listen to this, I would put a huge question mark as somebody who's looking at complex systems and policies with respect to complex systems, how this policy has been designed. One of the big problems with setting targets, if those targets are unrealistic, is the risk that Marcel discussed, that you spend a lot of money and get nothing in return from it. And that's a huge welfare loss because you could have spent it otherwise, but it is also, it may undermine the credibility of the policies.
Yeah.
Because people then don't trust politicians anymore if it becomes clear that they have had to spend a lot of money for something that doesn't work. And that's a big problem, not only for solving the problem, but also in the political process. It undermines the political process.
It undermines science too.
And it can undermine science.
Well, here's a scientific question from the audience. Manuel Lindenbaum. He says, thank you very much, Marcel. Chemotherapy is the climate change debate. He says it's right. It's a very modest statement, actually. He said, but so the uncertainty in the system and the lack of knowledge of the tipping points does put a pressure on timings and policy. So he says, what do we know about the triggers and the mechanisms that we can use?
What that we can use for what?
For the tipping points to find
finding tipping points.
Yeah, finding tipping points.
Tipping points is a really, really complex. I mean, if we talking about complexity, I mean, there are definitely tipping points in the climate system. If we go back in time, we see that there has been tipping points.
Very few though.
But the problem is that tipping points are totally unpredictable. So you could even go as far as saying that the fact that we have a rise in CO2, we don't know if it will bring us closer to a tipping point or farther away.
Yeah.
People tend to think very, very simple and say, yeah, well, if we go like this, we will go to a tipping point.
All over the edge.
We don't know. We don't know.
And it's part of the definition of a tipping point.
Yeah.
It's unpredictable. But looking at his question, have we been able, with the tipping points that we have seen in the past, have we been able to define what the triggers were for those events?
No. When we look at geological history, there have been a few tipping points, a few. What is more enlightening than the tipping points is the fact that the climate system as a whole is very robust. So instead of going from one tipping point to the next, the characteristics of the climate are its robustness more than anything else. So yeah, one can worry about tipping points that you cannot predict anyway. You can worry about anything. But scientifically, there is no sound basis for thinking or saying that it is about to happen again.
No.
There is one paper I'm actually currently reading again. It's from 2 years ago. It's a scientific paper, but it describes that the Earth seems to behave like a self-regulating mechanism. And how did they find out? That the northern hemisphere and the southern hemisphere have the same albedo. And what is albedo? Albedo is the reflection of sunlight.
Yeah.
But the southern hemisphere has a lot of oceans and the northern hemisphere has a lot of land. So you would expect, you would expect a difference, but the system is able to make it totally comparable, the albedo of the northern and the southern hemisphere. And
so a very important
really fascinating aspect of the climate system.
Incredible.
So what we're going to ask you, Marcel, we'll make sure Form Manuel and our other people who are asking us, we're getting a lot of questions actually on this point, is that we'll try and make that paper available so people can have a further read. I'm sure you can help us with that.
Yeah.
So I find this totally fascinating. Let's go to sort of a semi-closure. It's very popular now to be a Minister of Climate. It's a new role.
Yes.
And we have this role at the United Nations levels, probably EU, everywhere. So let's assume for a minute that, Kees, you're going to be the new EU Minister of Climate.
heavens.
Or you, Marcel. Marcel, start with you. I see the lights going. So first move to you, Marcel.
Yeah.
You didn't
You're
expect
going
that,
to be
Kees.
the EU Minister of Climate.
Yeah.
What are your first actions?
I would pull out the Paris Agreement immediately.
Oh, dear.
Because the Paris Agreement is totally symbolic. I'm totally with Trump on this. He said it's a really bad deal. For him, it is also a bad deal for the US because it means that the US has to transfer a lot of money and technology to other countries. But even as a whole, it's totally symbolic. People don't realize that even if you believe in the whole theory and the models and etc., that in Paris, what they promised is only 1% of what is needed. Yeah, and they cherish this. It was like we saved the planet. Yeah. And now in Bonn, you see already more realistic atmosphere.
Agenda, yeah.
Yeah, so get out of Paris and realize that there is a very funny comparison that they say the Stone Age didn't end because of a lack of stones. And the fossil fuel era in which we are now will not end because of a lack of fossil fuels. Some people say, well, they're gone in the end. No. Yeah. So we only are going to end the fossil fuel era if we have a good alternative for it. And the current alternatives like wind and solar and biomass are not alternatives by which we can manage society.
So
okay. we have to develop better technology, cheaper technology, and if that can compete with fossil fuels, then we can make the next step. Otherwise, we are not going to make it.
I couldn't agree more. When I would be Minister of Climate, I would end on the same day that I was appointed the subsidies on wind and solar. Wind is like the horse of 150 years ago. When we had horses to run the total society. Nowadays, even a huge number of horses would not succeed in running a very complex society as we have it today. The situation with wind is almost identical. More windmills will not help us to build a realistic society when it comes to our energy needs. And then, before abolishing the Ministry of Climate completely, because I think it's totally useless, I would do one more thing, and it has to do with this little ball that I brought with me. This little ball, metal, yeah, it's a little heavy, contains thorium, a radioactive element.
This is dangerous.
It's not dangerous at all. No, it's not dangerous at all. You can keep it under your cushion for the next 20 years and, live happily ever after, no problem.
Thank you.
The point is, and that's the demonstration of this little ball, in this little ball, enough nuclear energy is stored to help a human of 77 years old, the average age that people reach, throughout their energy life. So all the energy they need, warming their house, running their bath, taking airplanes to wherever, all the energy they need is contained during a lifetime in a little ball of this size. Well, that's a difference compared to windmills of 200 meters high.
I think you can start a political party with that, because you're basically telling
the political party in Holland...
I can continue to fly, I can continue to have my hot bath without feeling guilty.
Exactly. So, well, all kidding aside,
joking aside, yes.
I'm really convinced that nuclear energy on the basis of thorium is the only way to go in the more distant future. And I do believe that in 10, 15 years' time, we can have the first demonstrative reactors and very soon afterwards the first commercial reactors. And in that sense, in my view, the whole CO2 debate as we have it nowadays is rather superfluous, because whether CO2 is or is not the large monster that it's made to be or not made to be is irrelevant on a timescale of about 50 years, when we have all turned to nuclear energy and the whole CO2 debate has gone up in thin air.
Yeah, I appreciate that, but you also appreciate it when you say nuclear energy. We all think back of, you know, when I grew up in the 1970s, it was supposed to be the most dangerous and lethal thing one could imagine. Do you say that the technology on that front has also dramatically advanced?
Yeah, I would be very happy to come back to another session here to explain to the audience about nuclear energy on the basis of thorium. You will see that the safety aspects, the reliability aspects, the cost aspects, the realizability are all beyond doubt. And that all that holds us at the moment from nuclear energy is, well, I'm sorry to say, the old ideas about how uranium energy used to be. All that is
it's
past.
an old mindset.
It's an old mindset, and all we have to do, education is always difficult, but what we do have to invest in is extending the knowledge about nuclear energy in a realistic fashion. And then my expectation is, it will come to pass when I'm not here anymore, I'm sure, but
maybe before.
Maybe before. Let's hope so.
Let's hope so.
I hope it's realistic.
Good. I find this very interesting, because we're coming back to the point where you say it's only mindset. And only recently I was chairing a very large InsurTech event, and people said, oh, this is very complicated. And I now know the difference between complex and complicated.
That's very important.
And I said, well, actually, it's all there. The people with the ideas are there, the technology is there, the industry, society is moving, so why don't we do this? It's a mindset thing. So going back to you, Lex, coming back to our original purpose, what can we do with this mindset topic, that we really start to not only think differently about the complexity and uncertainty, but also act differently?
Yeah. First of all, pity that you don't ask me whether I would be the climate change minister.
Oh, well, I haven't asked you. Lex, what would be your first task?
Because I think that would be nice, and I would take both gentlemen as advisors. And I think what I would do to become more serious. I think what I've tried to argue during this seminar, if we look at the current policies, and of course we couldn't go into great detail, but I think to put it modestly, you could put great question marks behind those policies, the Paris Agreement, and I think what we need is a kind of a reset of being realistic and also rational about complex issues, and look at them from what we know and what we don't know, applying the principles that I mentioned earlier, so bringing back rationality into the debate, doing that by conveying what we know and what we don't know, let me call it objective information, and then have a proper, normal debate about policy, like we have it on all other policies, and not treat it as a kind of a religion and of a great threat to humanity. Let's be cool. Let's be cool, literally.
Let's be cool, literally.
Let's try to be rational, and let's take into account again that we have to do here with a very complex issue, and that on top of that, policy itself is complex.
Coming back to the point, how do you translate thinking differently into acting differently? Are there other segments? You know, we talked, for instance, before this session, we were also talking about, drawing parallels with other very sensitive issues in society, like taking care of the elderly, etc. how can we influence and think about the viewers as well? If you're a student or if you work somewhere, how can you make your contribution to that more neutral and realistic
I think
mindset?
it is important that we acknowledge, that we realize that the world is full with complex issues. You mentioned healthcare, immigration. Basically, all the economic issues are complex issues, and for me, it is important that we deal with them, taking into account the principles that I mentioned several times, and that also in our education we learn people what it means to indeed to act in a complex and uncertain world. And there again, let me again put it in a number of strengths that you need to apply, or principles that you need to apply, again without going into detail. But I think in such a world, it is important to be entrepreneurial,
Yeah.
to be alert,
Yeah.
to be resilient, to be adaptive, and to be creative.
Yeah.
And helping people to acquire these 5 strengths and building on them, I think that's the longer term way to go if we want to have better policies
Yeah.
for better lives.
We will have to convince politicians that they should not act politically correct, because that's what they are doing now. Yeah, you know, and
Yes.
and the
And
big,
not just on climate change.
Oh,
no,
in
exactly.
general.
Not
In
just
general.
on climate change, but sticking to climate change. You see that they decided in Europe in an early stage that we had to solve this with renewable energy. So and after that, there was no discussion about it anymore. So nuclear is not on the table now.
No.
No.
In Bonn, there was James Hansen, a very famous climate scientist from NASA, and he is now openly promoting nuclear, and he is really scared about climate change.
Yes.
And he say we can only solve this with nuclear, but this is like an
agree.
ideological battle that will have to take place. And we need politicians that are willing to do that and
Yeah.
not just decide to take.
The problem, Marcel, is a more general one, because the question was also a general question. In economic policy questions and policy questions, we politicians, and we cannot blame them for doing that, because that's historically
get
based.
voted.
Politicians base themselves on a view of the world that is not complex and that is not uncertain.
Yeah.
That they are in control, that they can control, that if they
Yeah.
build the right model, and that they then can apply the right policies. So total control, which is simply impossible in a complex system. And we have to teach them, educate them
Exactly.
in that area, and then apply, let's say, the right principles, and not only do it for politicians, but
Yeah.
do it more broadly.
What
Well,
if?
there is a big problem in education as I see it. When I look at the development over the last 20, 30 years, all I observe is that numerical literacy has fallen by the wayside. And if you look at politicians nowadays, the number of people that have an education in numerical skills is getting more and more limited. And people like to talk, and they like to talk a lot, but the basis of it is often lacking. And that's what we should improve.
That can be solved with good,
can be solved.
good solid advisors. And we all understand that the politician has to convey a message.
Yeah, and I think although I agree with let's say the flaws in the policies, we should not exclusively blame the politicians. I think it's a broader issue.
Yeah.
Societal.
Because to come back to one more point that you very lightly touched on, but I think even if you just look at the Netherlands and what we export, if you look at adaptive systems or preventive measures, people like who do water management, people who look at construction, we can learn a lot from Japan. If you look at how they have rebooted their whole mindset around construction of safe houses. Do these people take place in the debate as well, or are they treated as sort of the next ring outside the main topic because they don't bring a message we really want to hear.
They just take they take the smart position. Of course, they just take advantage of all the attention that is now around global warming. So they will not go into the debate. They just benefit from it.
Yeah,
They
But,
harvest.
no, I know, but
And this is fair, of course. And I noticed throughout the years that engineers, engineers specifically, they are not very interested in the fundamentals of the climate debate. They say, well, they say there is a problem with CO2. Let's
solve it.
Let's
Let's
try
solve
to
it.
solve it. And that's the way how engineers think. So even there, you need other people. Again, that focus on the fundamentals of the climate debate.
Exactly.
But for educating our young people going forward, you know, there's a very good place in each of those professions to come to help to a solution.
There is.
Whether as a scientist or as a...
If we could recreate a society in which the debate becomes open again and where the debate is not determined by predetermined ideas about certain problems, certain complex problems. That's a terrible mistake to make. If we cannot build a society with an open debate about complex issues, we're making a terrible mistake and we're bound to fail.
Yeah. Final question from the audience before we're going to conclude this. My light bulb does not work on theoretical power. I need real practical power. So the shortest of go-arounds, what sort of, you talked about nuclear power.
Yes.
What is the outlook that you reckon we can have practical application that even in our daily lives?
In
Short answer.
10 to 15 years we can
10
have
to 15 years we can have a different
certain
view.
working models. Certainly in 30 years we can have a very large impact on the total energy production that we need on the basis of nuclear.
I'm going to remember that when I have my wine at 85.
Yes.
Lex, how long before this hype as a topic flies over and it becomes part of the realistic, normal economic agenda?
Oh, that's. I hope it will, but I find it very difficult to predict when.
You don't dare.
Even the if at the shorter term is a difficult one to predict.
Yes.
But I hope that by trying to convey the right information, to try to see it in a rational light, in a cool light, that we can contribute a little bit to this happening in the not too far.
Okay, and to end with some fun, will Trump really pull out?
Yeah, that's the question. He said he will do, but I read that currently the negotiators of the US act like he is not going to pull out. So there is some confusion about that.
There is some confusion. Thank you. This was a very energetic and lively debate. Thank you very much. This concludes the program for today about climate change policy. Thank you very much for your active contributions. You saw me trying to moderate the influx and try and see which one to table, which one not. And of course, thank you very much to our faculty, Professor Lex Hoogduin. Thank you very much, Kees de Lange, Marcel Krok. Thank you very much. Note in your agendas, viewers, please. The next live GLOCOMNet panel discussion will take place on December 18. We're heading for Christmas at 17 hours, again, Amsterdam time. And in that session, we will discuss scenario planning, scenarios. We look forward to seeing you then. I'm Connie Dorrestein. Goodbye.